Good morning dear students. In the previous class, I have obtained the equation of refractive index of the prism. What was the expression? N is equal to sine of A plus D by 2 whole divided by sine A by 2. Sine of A plus D by 2 divided by sine of A by 2. Okay. In this equation, what is A? A is the refracting angle or simply angle of the prism. What is capital D? D is the minimum deviation. When it has been obtained, minimum deviation is the condition when the refracted ray will be parallel to the base of the prism. The refracted ray will be parallel to the base of the prism. For that minimum deviation, angle of there will be only one angle of incidence. For other deviations, for single deviation, there will be a two angle of incidence value. Nothing but one angle of incidence and one more is angle of emergence. The value will be different. In minimum deviation condition, angle of incidence will be equal to the angle of emergence. Okay. That is, in this diagram, what I have drawn in the derivation part. Okay. A, BC is the prism, principal section of the prism. Here, PQ is the incident ray and RS is the emergent ray. So here, in this case, deviation D has been obtained. For the minimum deviation condition, what happens? In case of when the incident ray shifted to or rotated through the certain angle, in order to obtain the minimum deviation, this refracted ray will be parallel to the base of the prism. So, this will be E and the deviation which has been obtained is called as minimum deviation. Okay. So, next, what happens if the prism is thin prism? Okay. Thin prism. If prism is said to be a thin prism only when angle of the prism, nothing but in this case, this angle, the angle of the prism should be less than 10 degree. Angle of the prism should be less than 10 degree. Such type of prism is called as what? Thin prism. Okay. So here, if the prism is thin, we can Dispersion. That color will be in the form of vigor. Okay. Here violet will be in the bottom section and red will be in the top section. If there was no any prism, this beam of light, white light would follow a straight line path. Next, so deviation value is different for different colors. Okay. For violet, this value is, let it take it as dB. Okay. Next, this is dr. dB is the deviation produced by the violet color and dr is the deviation produced by the red color. Okay. Deviation produced by the red color. So here, when you see the diagram, for each and every value, the wavelength varies. Okay, color more. Next for violet color. Violet is the most deviated value. Next, refractive index is also more deviated. Speed is less and wavelength is also less for the violet color when we compare it to the red color. Okay. Next, one more term, that is angular dispersion. Angular dispersion. Angular dispersion is nothing but it is the difference between the deviation between the two colors. Okay, it's the difference between the deviation of the two colors. If theta is the notation, then the value will be dV minus dr. dV is the deviation produced by the violet color and dr is the deviation produced by the red color. If we substitute in terms of d equal to n minus 1 into a, I can write this in terms of directly and right. You can write in the home nv minus nr into a. You will get this value where nv is the refractive index of the violet color and nr is the refractive index of the red color, and a is the angle of the prism from which we have obtained the dispersion phenomenon. Okay. Next, dispersive power. Omega theta by delta. Theta means it's the ratio of angular dispersion to that of the mean deviation of the two colors. Okay, so we can define the term dispersive power. Dispersive power is the ratio of the angular dispersion to that of the mean deviation of the two colors. That is nothing but delta. I will write for dV and dr, dV plus dr by 2. Okay, you can substitute and obtain the expression, but you should remember what is dispersive power. It is the ratio of the angular dispersion to that of the mean deviation. Angular dispersion means what? It's the difference between the deviation produced by the two colors. Okay. Next, let's see some of the natural phenomena which occurs in the nature. Okay. You have heard the term scattering of light. Next, rainbow formation. I think you have seen the rainbow. Yes, isn't it? Rainbow formation. Next, white color of cloud, blue color of sky. These are some natural phenomena. Okay. Let's see the formation of the rainbow. How does the rainbow occurs? So, rainbow is formed due to the dispersion phenomenon, mainly because of dispersion phenomenon. Along with that, remains two more phenomena occurs, that is refraction and the reflection. Okay, dispersion, that is rainbow formation. Main reason is because of dispersion. Along with that, refraction takes place and also reflection, that is here interaction along with that dispersion. Band of colors will be same. Next, what happens when we get another outer layer, another side of the tiny droplet? Okay, what happens? It satisfies the total internal reflection. How we can define the total internal reflection? When a ray of light is traveling from denser to rarer medium at particular angle of incidence, the ray is totally reflected. Okay, ray is totally reflected back to the same medium. Okay, finally the light ray emerges out. Okay, next, one more same phenomenon. So it has been observed that the violet color will be present here. Violet color will be formed, or the wavelength of the violet layer will be seen on the bottom of this rainbow formation. This color will be violet and upper value will be of red color. So here the below region is violet and upper portion will be of red color, or we can say violet in the inner portion and red in the outer layer of the primary rainbow. With respect to the observer eye, the deviation value of violet color is, with respect to the observer eye who is seeing that rainbow formation, for him the deviation value produced by the violet color will be the intensity will be little bit less when we compare to the primary rainbow. That is how primary rainbow phenomenon or primary rainbow occurs. Okay, rainbow formation occurs mainly because of dispersion along